This livestream series is sponsored by Slice Engineering and the Mosquito Magnum Plus hotend. Push absurd amounts of filament while maintaining the structural integrity of the Mosquito design. The Mosquito Magnum Plus can be configured with up to 100 watts of heating power, redundant 500 degrees Celsius rated thermistors, and air or water cooling. I'll be using the Magnum Plus for this build, and you can find the links in the description below. Also, Do It 3D, the Voron printed forward team, and Lineo were kind enough to provide some of their high quality parts for this build free of charge. I've purchased the rest of the parts on the regular, like the FormBot kit, upgrades from Fermio Labs, and little bits here and there. You can find links for everything in the description below. Now, let's get started with the build. Hi, we're back. We are back at building a Voron 2.4. It feels like it's been forever since we did the last one here, but for some, I don't know. Live streaming is always exciting and exhausting and exhilarating. So welcome everyone who's here. I saw that there's like 200 people already here, and I'm not even starting anything today. I'm seeing Nero's here, a bunch of familiar names as well. Connor just said a minute ago, hey, it's his first live stream that he's actually catching live. But as you know, you can always rewatch these. If you run out of time watching these. And somebody said, hey, this is like my soundtrack to working from home. Like, please work, do your job, and then, you know, watch these streams. I don't want to distract you from doing the actual work. So, yeah, today we hopefully are going to be completing the mechanical build, as the title of the video says. Like, the actual mechanical build, as in, we should have X, Y, Z, and E. Oh yeah, I remember we still have to build the extruder. We'll see. So everything that is mechanical, this thing should be fully movable. It's not going to be powered up yet. I think that's going to be still a bit further out. So like electronics, wiring, all of that will need to be done separately. And yeah, for wiring, I just want to have everything built. And then I'm probably going to have to take apart some stuff again. Oh yeah, by the way, new top camera. I put the GH5 that used to be there. That used to be that used to be that perspective. That is now the overhead camera. So the overhead angle should be a lot nicer. Yeah, for example, this end-stop bracket I will need to take off again and add some short bits of wiring and connectors here. Just so that it can mate up with the wiring loom that Lineo sent over. So this has all the connectors for the board. Well, almost all the connectors for the board side already. At least it's got all the crimps on there. And yeah, the other side has these Microfit Juniors on it, on all the connectors. So that is something we're going to have to do at a later date. And like I said, I'm not sure if I'm going to do wiring on stream because I find that, I would find that boring to watch. I would rather do firmware config and figuring all that out on camera with you guys, because configuring Do It, I've done that 3-4 times from scratch on a printer, and it's always been quite a brain teaser to get everything set up in the way where, you know, in the end everything works as intended, especially with a setup where you have a bed probe. Oh yeah, we still of course have that angle. We have this is upside down. We have a bed probe plus that tool length sensor. Oh, that. Clickies. So yeah, that's going to be something I'm going to have to figure out, I think, off camera. I might do a time lapse and add that at the beginning of the stream after that. Yeah, but for today, like I said, mechanics. Thank you for the 50. I have no idea what currency that is. Carl, glad you're enjoying the stream. And no, sorry, Dolly is not with us anymore. So Dolly, for those of you who don't know, was my Prusa Mark II, not really clone, but like cheapo knockoff build. And I have since disassembled that. It was a bit too far on the super budget side. Like especially the setup with the bed was a bit dodgy. It would have needed quite a few overhauls. But those of you who did build it, I think, or I hope, built it a bit more reasonably than I did on that stream. And of course, building stuff on stream, there's always the pressure of you guys watching and trying to get it done quickly and all that. So yeah, but if this feels like the Dolly build, maybe that's intentional. Maybe this was kind of an attempt to get that feel for, hey, we're building something together and we're building a printer. That's a kit, and some stuff might go wrong, and it probably will. We'll see. Stefan's here as well. Hey, Stefan. Good to have you in chat here. Fourth stream and still mechanics. Well, Stefan, I mean, you did the entire build off camera, right? You had a camera running, but you edited that. I'm just pulling through as far as I can. Like I just said, I'm probably gonna have some stuff I do off camera. But let's check out what we are up at. So I did scroll through the manual a bit. Oh yeah, we still need to build the entire extruder. With a pancake motor, yep. But we stopped last time when it comes to belting everything up. So that was the step where it's like you have the X carriage and you attach the bearing or the carriage to the bottom rail. God, I'm nervous now that I know that Stefan is watching. So this is the back side of the extruder. Front rail is here. And we skipped the bottom rail. Usually there would be another carriage in the bottom here. But as advised by the Voron team, I left this one out because the front rail is enough. And yeah, feeling how rigid this is definitely more than rigid enough to carry a hotend. There's like zero slop that I can feel right now. What's the point of live streaming if stuff doesn't go wrong? Yeah, exactly. Shadow, what are you building? Well, I mean, look at the video title, like it's all in there. Anyways, that's what we're gonna do today. So I stopped at adding the belts because I was like, okay, belting's gonna be a part where I might screw up, and I don't want to screw up, and essentially, well, oh, that's the switch block. Okay, I don't want to screw up because if you cut the belts too short, like that's it. I think I do have some extra belts, but they may not be the same gates belt that the kit includes. So that's actually a plus on the FormBot kit. These, at least according to the label, yeah, these are Gates power drive, genuine Gates power belt. Yeah, very good power belts. Gates power belts, which are a lot more rigid and a lot less elastic than the knockoff belts. All right, cutting the belts. Let me just check if there's anything in here. Cutting the belts, securing the belts. Tighten them down, yeah. And these are these little flanged widgets. Those are the red accent pieces that are going to clamp both belt loops in place. So let me see if there is actually no. Okay, so it is literally add belts. That is the manual step. Wow. There's nothing else about belts anywhere, right? Nope. And then it's the Z-axis. So basically it's add some belts. There's how the belt is supposed to go, the entire belt path. You can see that on the left here. So it's two loops. It is two levels of belt that a Core XY system has. And that's one. And that is the other. So you can see on this side, it wraps around the motor back here. And then it goes all the way to the front. That is the upper level. Well, there's only one way to assemble these. And then the other loop wraps around the motor right there, and it goes towards the front on that side as well. Whew. So, first thing to figure out is which belts these are for XY, because we have GT2 9mm at 1 meter and 10 millimeters. We have 6mm at 1 meter 80 centimeters, and we have one that's unlabeled, but that is a 9mm as well. I think that is part of that. So I believe these four Oh yeah, I can switch through different crops on the top zoom camera now. Ha. So that I believe is the ones for the Z-axis, and then these two 6mm ones, 1m80. Yeah, that sounds about right. These would be the ones for the XY drives. Do these have? Yeah, there's a label. There is the label for the Gates belt. Gates Power Drive GT LL2GT. By the way, this is kind of a pet peeve of mine. The name GT2 is inaccurate in the way that it's used. These belts might be GT2, but they are just GT belts for the most part. These are labeled just as Gates Power Grip GT, and that's fine. Because while the way that these are labeled is kind of weird. The thing is, if you're saying GT2 and you're referring to a 2mm pitch with that, that is wrong. Like a 2mm pitch belt is always 2GT, as it is correctly labeled on here. So this is a Gates Power Grip GT LL2GT. If it's a 3GT, it's a 3mm pitch. And you can get both HTD, which is the like historical low performance profile that is compatible with GT. You can get GT, and you can get GT2, and I think there's even a GT3. You can get those in all sorts of different pitches. So you could get a GT2 in a 5mm pitch. Totally adequate. But yeah, the way that naming is usually used is when it's GT2, it is referring to a 2mm pitch belt. Anyways, so there is really only one way. I'm nervous to start this belting process because this might be a bit finicky. Let me see. So I guess I'll start at this clamp right here. So I'll start at the clamp that holds. Actually, if I push this back, it might be easier to see. I'm going to start at this clamp right here, and I think I'll clamp this side down already just to keep it in place. And just to make sure it's not like sliding around or anything. So and I'm already inserting the belt backwards. Maybe if you rotate, you guys can see a bit more of what I'm doing. So that is backwards. It's like this. Just goes through to the side. And then this bit right there, where it's pressing up against, that has that tooth profile to it. So how are we supposed to cut these? Cutting belts. To cut both XY belts the same length. You can pre-run one length and then cut the other using it as your guide. So basically you would thread in one and then take it out again and then cut the other one the exact same size. Okay. So I'm going to leave... Why can't I just leave these too long and then cut them to size when I... Well, I guess for one that works. But yeah, theoretically these should be the exact same size, the exact same, well, size, the same length for both of these. Mesh them together, yeah. You don't need to cut the belts, they're pre-length in the kit. Okay. So yeah, supposedly they are 1010 millimeters long. Kits come with pre-cut lengths. Okay. The manual assumes you have one continuous spool at first. So I guess I'll just leave this one sticking out slightly. Oh, that is a bit dark. I'll leave this one sticking out like one tooth. And then I'll just move over to belting this through. So So this side, and this is the bottom belt that we're doing. So you go through here. and then you go back. You go back, you go back. I guess if I pull you through to the front. And did it already twist it? No. So you go to the front. And then you go back through here. There's an idler there. Oh, that's actually a pretty tight fit on that idler with the two flange bearings butting up against each other. And that's there, but it is running smoothly. At least as long as it's on the idler. Did I actually miss the idler? No, just jumped off. This is probably a pain to watch, especially because I'm already having a hard time keeping track of where stuff is happening. Come on. There. So that's there. Then this corner over here has two bearings or two idlers stacked on top of each other. That's hard to show. There we go. That is that corner. And then this rides... Oh yeah, this is going to get threaded through the motor up top here. So that might be a tricky one. So you go through here. Then I guess we can first thread it around the idler and then back again. Because there are plenty of openings. The pulley is in the correct spot. There are plenty of openings to thread this around parts. So if you kind of don't get it into exactly the right path first on first try, I think I painted myself into a corner here. If you don't get it exactly right on the first try, you can... you can most likely feed it out one end and back into another one. Come on. Yes, there you go. So at the end I can bend these around. That's fine. But you do not want to crimp or kink these belts in the center, because that's going to be a spot where whenever it runs over an idler, it's going to give you a little bump, because that spot's going to go, it will want to snap into place. And that may or may not be visible in prints. But definitely you don't want to get these kinked in the middle. So we are going to go towards the forward idler, towards this guy. So this just threads through. And then this is the tensioner that we assembled. There's an idler in this red part that will allow the belt to get tension, and I'm going to put this at the lowest tension for now, because if this belt is actually cut to the exact right length, then, you know, if I were to already put this in the tension spot, I wouldn't be able to clamp it down at the tool head. Well, that's interesting. First of all, this belt jumped into the aluminum extrusion. And also there is a toothed idler in here. How is did we flip the belt? Oh yeah, I flipped the belt. That's a problem. Okay. I was wondering, like, why would the teeth, why would the back of the belt run against the teeth? But then I realized, okay, would be the wrong way around there as well. So I flipped that. You shouldn't flip the belt. Shouldn't put a 180 turn on it. Though I think some early printer designs actually did that, where they had the belt not running flat but had a twist in it at some point. And that kind of works, though it only really works with the 5mm or 5 or 6mm belts. If it's a larger belt, that's going to cause some issues. So you go through here. And the Voron 2.4 here is pretty consistent when it comes to using toothed idlers for the side of the belt that has the teeth on it, versus using smooth idlers or a pair of those F695 bearings for the side that has no teeth on it, that is just smooth. So with a small, oh, that is pretty long. Wow. So with a smooth idler running over the teeth, you may be able to see some of that bumpiness, but yeah, not with. There's my screwdriver. Not with running it over a toothed idler as well. Don't cut. Just make them equal. Okay. Don't cut me now. So just pull the shorter end out. Okay, so make both the loose ends equal. All right. So you come through here. The thing is, I can't really tension this now because, well, I guess I can. Because these two sides, what I thought would happen. So if I tension this belt, there is going to be these two sides will want to compress against each other. But because we have the x-axis in place already, that should be rigid. So yeah, make sure your belts are the same length first, though. Well, it's too late for that. Okay, so this I'm just going to put to half the length, and I'm going to undo this one again and also pull through a bit more. I just put this onto the shortest possible length because, well, it's important. So what do the okay, so basically I should take this all out again. Okay, at least I know how it's getting threaded through right now. Can you show how it will move with only one belt installed? Well, we're going to get to only one belt installed again in a second. But for now, I guess we're pulling this all out again. Oh no. So yeah, I guess I can kind of show you because there is some friction. If I pull on this end that's at the tool head, it's just pulling forward. Same actually on this side. But if this was clamped here, and I pull here, you can see it tries to move diagonally. And that is kind of the secret sauce of Core XY. It's basically... Oh yeah, I'm dragging through the motor, that's why it's so tough. Core XY is basically an XY system built at a 45-degree angle. So one of the motors moves this way diagonally, the other one moves this way diagonally. Okay, and then this should be the second one. So let me try and compare these. So as far as I know, the best way to make sure these are of equal length is just to mesh them together like this. So with the two toothed sides facing each other. Then, just by sliding it through my fingers with the teeth, unless you can feel it skip, This should be making sure that it's equal. Nope, I can keep feeling it skip. Almost looks like one of these has a bit more tension to it than the other. I'm sure this is super exciting to watch. I just want to make sure we don't skip a tooth. I'm trying to make sure these are exactly the same tooth length. So I'm guessing with the belts matched in tooth length, we can count back and we can make sure we get the same amount of teeth sticking out of the X carriage, and that way we know the amount of teeth in the system would be identical. Equal tension, yeah, at the end you can simply count the teeth sticking out. So yeah, these, look at that. I believe I did not skip any teeth. These are different by actually a bit over a centimeter. Camera, come on. No, that's not what I want to focus on. There we go. That is the difference in length that we're getting. It's quite a bit. That should be better. Now I don't know which one of these I started out with one tooth extra. But I think one tooth off shouldn't be that big of a deal. Yeah. Tintech, that's exactly what I'm not sure about. But right. These are the exact same length. And now we can actually thread it in the correct orientation. So I'm gonna just give it a bit of stick out on that side. I can get the focus perfect here. I'm gonna give it a bit of stick out, and then once everything is through, I can adjust it. What am I doing? I am trying to get these belts the exact same length. Hold on. Who's writing me? Is this important? Nope. That's my buddy having food again. Oh well. Last time I was grilling out. Today it's asparagus. Oh man. You can mount the belts flush on the side you're starting on. Okay. So flush as in I'm going to leave one tooth as an overhang just to give me something to grab onto. If I need to get back in and pull it out, I can... Actually, I can clamp the other one as well while we're at it, so I'm not going to have to undo this again. Nope, that's the one we're doing right now. So you go here the same way as the other one. By the way, if you guys are having a tough time seeing this, well, the perspective isn't that great. But I'm also having a tough time seeing this because the lighting from this side is pretty dim. Got the studio set up to look nice on camera. That also means it's not always the most functional lighting. Like that perspective, oh look at me, nice soft light, bit of an accent light from the side, but actually from the back, from behind me, there is like zero lighting, which means I'm working in the dark where you guys get to see for the most part. That camera also has a horrible angle for lighting. It's mostly backlit. Oh well. I need to fix that for the next live stream at some point.
Is it worth studying architecture/engineering in Germany for a semester? I love the engineering and design in Europe, especially Germany.
Thanks for the 5, Kyle. Is it worth studying architecture engineering in Germany for a semester? Well, I don't know what a semester is going to give you. I've studied engineering in Germany for 7 semesters, 8 semesters, I don't remember. Just a regular bachelor's degree plus, the time that it took to get my bachelor's thesis done with timing at the company that I was doing that at, etc., etc. And I honestly, I don't really have a comparison, like whether, the university here is better than international ones, but I guess it depends where your main degree is happening. But if you, in either case, if you get the chance to, why are we on that angle? That's not what I wanted. If you get the chance to do a semester in a different country, I mean, I would take that just for, not for, it's gonna add extra value to my degree. To be honest, nobody cares about your degree. It's about what you can do, and a degree is like one of the worst ways to judge that, in my opinion. Just the extra like cultural experience, I think that's definitely worth it. So if you have the chance, do that. Why not? And also, like, it doesn't matter if it's Germany or some other country. So yeah, if you have the chance, go for it. It's like eating tons of garlic. You'll regret it, but it's so good. I've never regretted eating garlic. Not once. That might be because I stopped I stopped caring so much, but garlic is awesome. What is the most valuable skill you get from university? Ooh. I don't know. I don't know which specific skill I would point to there. No idea. The thing for me is, as you may have been able to tell, I'm not a person who does well in like in like a lecture setting where it's like, oh, here's a guy talking about stuff and you just listen and you learn, and you're supposed to learn, and that's it. I prefer doing stuff hands-on and using or learning stuff bit by bit as I need it. So I've learned I've learned about some programming stuff. I'm doing Python right now. 3D printing, yes, I did in the context of university, or I guess University of Applied Sciences. No, what technical university is what they're called right now. So I got into that through university, yes, but that was only like an opportunity to jump into it. I did not need university to get into 3D printing. It's like, I enjoy that process of trying things and figuring stuff out as you go and failing at it and kind of picking up knowledge here and there as you need it. So, you set out to learn one thing, and in the end, you know about a dozen others that you had never intended to learn about. That is kind of what I really enjoy, and university didn't really give me that. Though, to be fair, I had a few professors that were actually really good, and that I still that I did enjoy the lectures from. But for the most part, you go up here. For the most part, I don't feel like university for me specifically did all that much. Like, sure, I got knowledge out of it and education out of it, but like I don't feel like like it was time spent efficiently. I could have learned more in a different setting. But that's that's a very individual thing. Why no background music? It's hard to find background music that everyone likes. And if I pick up music, like that's going to be... that's basically going to be a day of picking up music for me. If you want background music, just put on Spotify or something. Also, I cannot just put on copyrighted music from Spotify. That doesn't work. That's going to get me demonetized or the video deleted pretty quickly. Would it be possible to show how you route it at the back? Okay. There's you routing at the back. So the one side goes through the motor. This one goes through the pulley up here, and then the other side right there, that just goes along the back, open like this. And then this one over here goes through the motor on the other side. Yeah, I guess one more thought about university. Like I said, for me, that is not, lectures, etc., is not the way that I learn. So I was like, well, bachelor's degree, I guess that's gonna be it. Like, that's all I came for. It's that piece of paper that you need. If you want to work as an engineer, you need some sort of a degree. And like for me, it was just a call. Okay, I don't want to do another master's on top of this. This is not something I really enjoy. I want to get out there and do something. And I guess in the end, that somehow worked out. There is one loading screen tip in the starting soon screen, which is like, everything's gonna be okay. And that's what that felt like. Like, sure, you could have done more on university, but like, whichever choice you make, as long as you stand by it and you do that 100%, stuff's gonna be fine. Yeah, so for me, that was the call. Hey, bachelor's degree, that's fine. Stream beats. Yeah, so the thing with okay, totally different topic. Stream music. I do have an Epidemic Sound license, and I very much like that. I think it's even linked in the video description. And all the music you hear on the channel these days is from Epidemic Sound. The thing with like free music and like free music libraries and no copyright music and stuff is you never know when they're gonna come for you. Like it might be okay at the time, but they might change their terms, or they might, I don't know, do something, and all of a sudden, hey, your entire channel is demonetized or is monetized by someone else because they delete the original videos where it says, hey, it's fine that you're using this. It's just, I don't trust those sites. I've used them in the past, but always left me with a fishy feeling. So for me, properly licensed music, Epidemic Sounds. But I mean, hey, if you would like to have some background music, I guess you can have Stream Beats open in the background too. That's up to you. So, second clamp going on. This is what we're looking like right now. It's kind of slippery with the probe sticking down so far. There's that. So this side has the belts flush, well, at least one tooth sticking out, and then this side has them pretty much at the same length. I guess that's what we're going for. So these need to go. Yeah, these are fine. I don't need to count these. I don't have an offset, so I'm just going to clamp these down as is, and the rest, I guess, is going to be the job of the tensioners. Don't tension XY. Yeah, so this barely has any tension on it. It's just I've taken the slack out, but that's it. Okay, so there's no skew. Oh yeah, you can see like how little tension there is. Barely anything. Did that slip? No, it's just some stuff settled. Okay, so that is the belts in. 3DP Mamish, I believe the reason why we're putting the belts in now is because, well, it's easier to get to, and I missed the trash bin, and because we did count the teeth, or at least we made sure they are the exact same length, and it doesn't, from what I understand, is you don't want these belts to be, that the more important thing is to have these belts the same length so that the kinematics in the end work out. If you pull them to the same length, you might get these racked, or if you adjust it in the frame, it might also be racked without you knowing it. So that is my understanding right now of this setup. When will you square up the gantry? In the frame then, I guess. So it's two different components. It is the belts being the same length and the frame being square, or the gantry being square, and that is something that I think is going to happen in the printer, or in the frame. Theoretically, yeah, this shouldn't jump around, right? Okay. Alrighty then. Belts, cutting belts not cut yet. Belts are still, so hold on, belts are still loose. Tension them enough so that they don't hop off the idlers or pulleys. The final tension will happen in the frame. So these are on the pulleys enough, I think. They should stay. So we got that. Heat sets. All right, let me fire up the soldering station to polycarbonate temps. And yep, these two need heat sets. 2 heat sets, 2 M3x40s. Oh, we need a hotend now. Okay. Hold on. So with the mosquito, this is M2 screws, isn't it? The top of the mosquito, that is M2 or M2.5 screws. It's not M3 if I remember correctly. Nope. 2.5. Do I actually have mounting screws for this one? Whoa. This might be a problem. If I knew where I had my box with the mosquito parts. Wait, do I not have? No, I mounted that differently. I mounted that one differently a while ago. Okay. So we might need to, and I don't have, my screw assortments. Oh, hold on, do I have some specialty stuff in here? No, there's just grub screws. Do I have some M2 screws somewhere? But not in here, I think. Nope. So I'm gonna need to find some screws at some point. Let me get these parts prepared though that we're gonna need for assembling everything in place, because then it should just be. Actually, you know what? I'm gonna leave this out for now and just assemble everything without the hotend. Yeah. So that can just drop in, and the way that it's mounted in these parts. Oh, look at that! Nice print quality. The way that it's mounted is just through the. Well, I'm gonna do it like this so we don't actually bend stuff. Goes in here, goes in there. There we go, and it's actually held in place at the bottom here as well as being screwed in through the top. You can see that center slot there. that center slot there. That's for the filament. And then we have 1, 2 M2.5 screws that are going to hold everything in place. All right. And then I can decide which orientation this can go in, whether it's going to be like that or backwards. Come on. You are a tight one. Backwards like that with the printed side facing. I guess that's the user side, the visible side then. All right. Somebody asked, hey, which materials did he use to print with this, or which materials did he use to print all these parts? So the black and red parts, except for the X carriage and the fan shroud, the black and red parts were printed by the Voron printed forward team. If I remember correctly, it was Andreas from the German team. In Isan ABS Plus, and the red one was something else. But these are ABS. And then the parts that I printed for the carriage are Prushament PC Blend. Because I was told the Mosquito Magnum Plus likes to melt stuff because it doesn't have a sock around it. And I just wanted to make sure that, you know, whatever's around it would not melt. Because that would be bad if stuff melted. And, you know, polycarbonate, we saw that last time already. Getting these heat set inserts in is something that requires a lot more temperature than in ABS. So I feel like, you know, these parts should be a lot more temperature resistant as well. And I don't think that's where the heat set insert actually goes. Hold on. Let me double check. Oh yeah, that is where the heat set insert goes. So 2 on this side, 1, 2 here, and then 2 on the back side. Did I have a choice of color for the parts? So I was asked which color I would like, but it was like, hey, do you want... So the Voron team actually provided these through PIF, and they asked me, hey, which color would you like? It was, is the red and black okay? And I was like, sure, red and black always works. And it's matte black, so that's even better. Oh, this soldering iron is falling apart. That is nice. So the tip was falling apart last time. Now it's the connector on the other side. Fantastic. But yeah, this was pretty late in the process that they offered to send me parts. I was like, well, you know, if you want to send some, I would appreciate it, but like, don't start printing stuff off in a rush just to get a different color scheme going. Like, if you have some, that's fine, and if they're red and black, that works perfectly well. Doesn't polycarbonate release vapors when really hot? Possibly, but so does ABS. So, you know. But I mean, hopefully it's not going to get that hot. Are we on Zoom? Yeah, we are. Yeah, and even at 280 degrees, this still needs a lot of convincing to sink in. Andreas is asking, how many heaters and thermistors are you planning to use on the Mosquito Magnum Plus? So currently my Mosquito Magnum Plus is outfitted with dual heaters and a single thermistor, I believe. Yeah, 1 thermistor, 2 heaters. It does take up to 2 heaters and 2 thermistors. There is a recommend. So thermistors are for redundancy, basically. If one of them fails, you have the second one to check against, and if they diverge by too much, basically the printer gets shut down. But it went in at an angle. Nah, that was perspective. It's fine. It's fine. So thermistors are for redundancy. The extra heater is to get you I guess a 30-watt heater would run out of steam at the flow rates that they're claiming. So you have 2, but also 2 will allow you to get to higher temperatures. Now, the thing with using 2 heaters in the Mosquito Magnum Plus is they actually require, or if you buy one, you are required to agree to using an all-metal mount for it. As in, from your carriage to the actual hot end, you only have metal components, which we do not have here. So I guess in this configuration, a dual heater setup would not be recommended or advised for by Slice Engineering. Does Do It or Repro Firmware support dual heaters? You can hook them up to a single output. That's no problem. So that's the Do It boards that I have plenty of power for, well, it's 4 amps roughly, a bit over 4 amps, for supplying 2 heaters out of 1 output. So that's fine. So that's an extra sandwich part, I believe. Does the Magnum come with boron nitride applied? I don't know. That's the standard part. That's the extra one. I don't know if they come assembled like that at all. So Mosquito sent me, or Slice Engineering sent me that Mosquito, which means it's probably been assembled more than you would get it assembled, but I am not sure. But mine is in a ready-to-use state. So we need M3 by 16 and M3 by 40. And I can find neither one. So these are the M3 by 40s, I know that much. Forbidden toothpaste from hell, yeah, don't I mean, I guess you could brush your teeth with it, but don't. Not recommended. M3 by 16, there they are. 100 watts are overkill? Probably, yeah. So these go in here. I'm just gonna assemble it without the hot end for now. Also need to trim the wires on that thing and get some, dropping stuff. I do need to trim the wires and get some of those Molex Microfit junior connectors on it, because I don't really want to run these wires through the drag chain. I want to have the proper Haloflon wiring going through that. So you actually, I still have I still have some zoom. Yeah, these parts, these are, I believe, fiber reinforced nylon, which I don't think is a recommended material, but that's what I have for now. I might reprint this. I don't know, extra hot and framey parts. I might reprint this in polycarbonate as well. So this is the Mosquito mount that fits around the Mosquito's parts. I might just reprint that in PC as well. So clipper on Do It. Yeah, I do have. Actually, I should probably insert the screws here first. I do have a Do It 3 for this build. Does that actually thread into anything? I do have a Do It 3 on for this build, which I do not believe Clipper runs on yet, especially because you need the CAN, what is it? It's some type of CAN protocol. You need that to communicate with the extension board, which I will be using. So I'm, oops, you were in crooked. I am not sure I would be able to use Clipper for this build. I will be using Repro Firmware as it stands. So 2 screws in here that don't really thread into anything. Will these thread into anything later? Possibly. Possibly those 2? I don't know. But these M3 by 40s, they just go through like that, and they stick out the back ever so slightly. If I push in here from the back. Oh, okay, we got some more. I thought that was all that they were getting, but come on, there we go. Okay, so these are going to thread into something at some point. So yeah, like I said, cool thing about this this fan shroud is you actually have, look at that, you have the part cooling fan sitting up top. This entire area is for the hot end cooling fan. You have the part cooling fan sitting up top, and it gets ducted around the entire assembly, and then it comes out the back. So I guess you get some pretty cool air sucked in up top here. And you get some, yeah, you get some really good cooling effect on your part if you're printing PLA. Of course, you can print pretty much everything with the Voron because it's basically enclosed. So. Right. Is there a wiring diagram available for the Voron 2.4? Well, the thing with wiring is there's no like diagram, etc. needed. You just go from your board to the component directly. I don't think there is wire routing per se in the manual, but that should be fairly easy to figure out because there's drag chain mounting points that should guide everything into the appropriate spots. And then it's just finding a path from your main board in the very bottom compartment up to the component you go into. So, you know, this entire wiring loom, it's just straight wires from the main board to your component sides. Should be pretty easy. But of course, if you crimp everything yourself, that's going to be a bit of work, just a bit of work. Pre-wired wiring looms, they're 120, 130 bucks, but worth it. I would say I hate crimping so much. All right, so there is our carriage. 2 screws. Oh, there's 2 more screws there. 130 bucks for some wires. Well, it's 130 bucks for some wires plus the crimps, the crimping, the connectors and all that. Oh, I just noticed I actually have a layer shift on this one. Whoops, might need to reprint that. Or I might not. So yeah, it's if you want to spend the time yourself, sure, go for it. Nobody's stopping you, but especially for a build like this where it's high condensate pump, especially for a build like this where there's people watching, you guys, wanting to be entertained somehow. I guess getting pre-crimped stuff is worth it for sure, just to save some time. So I see. Okay, so these 2 screws go into these 2 threaded inserts, and then we have 2 more screws. I guess this is the point where I should trim the belt. Or I can just squish it down and pretend it isn't there. No, not quite. I mean, again, I'll be taking this off anyways. I'll be taking this off again and installing the hot end anyways, so. Just get this on. So, yeah, I'm just going to pretend the belt isn't there. Fold them back into the little cavity. Yeah, enough of a cavity available right now. So there's 2 more M3x16s. It's these that thread into those top holes, those 2 top latches. So right up here, there's 2 more bits that go in. Actually, what am I doing? Why am I screwing this together by hand? I've got a power tool for this. Look at that. Look at that torque limiter. Look at that clutch. Come on. There we go. That was basically the perfect amount of torque. Don't tighten them too much. Well, whoops. Yeah, we'll pretend those belts aren't there. So those are in. That's the theoretically where the hot end goes. That's in. Right. Test fit housing. Make sure to test fit the hot end housing. Yep. Clockwork heat sets. So this is the extruder that we're building next. Those are end stops. Just for location, they need to be slightly loose. Yeah, there's a bit of a gap because we squeezed in the belt. But don't worry about it. This is coming off again anyways. Tapping plastic with an electric screwdriver. I'm surprised that the clutch on this guy is light enough to not strip these stuff. It's fine. Right. Extruder. So I guess you are going off to the side for now. And we're building the extruder next, which is going to sit on that carriage somewhere. I'm just going to leave all the parts on the table for now, because we are running pretty low on. That is that an extra? No, that is a cable cover that we're going to need later. We are running pretty low on printed parts, and I think we can spare the space that this takes up. It's an exciting time every time the power driver comes out. Trust me, it is exciting for me as well. So we need, let me see, so we probably need this. That looks extrudery. We need this. I can already see this on the, oh, and we do need heat sets, so let me preheat this. We do need this part. We also need this. This is the drag chain mount with the 3 holes. So that is the generic drag chain mount. And there is the other one with the 2 holes, which is for genuine Egus drag chains. 2 holes, 3 holes. Then anything else? Oh yeah, this little hook thingy. Is that this? No. There is a little hooker. That is, I think, the smallest part in the... No, we've got these 2 nut carriers. Almost the smallest part in the entire build. You we don't need. Rail alignment parts we don't need. These we're going to need later. And there is another part for hot end mounting, so if we were using a... I guess this is for a dragon or something. You would use this instead of the part that we just used, so we're not going to use that either. We're not going to need that either. Heat sets. 1, 2, 3, 4, and then 3 more for the generic mount. Alright. So let's get those heats set. You need one in the end. You need some here. Here's a little fan shroud, little air guide. So this side gets a single heatset insert in that hole. Alright, let's get you in. Wow, he's still at it. Well, what did he expect? Did he expect me to give up, Sean? That goes in so much more satisfyingly smooth than into polycarbonate. Wow. And then these go in from that side. Next page is also all the heat sets. More heat sets. Oh, more heat sets. Okay, so we have more parts coming up. So let's do these. Thanks for that. Let's do these and then the rest.
Thanks for the well thought through stream. I really enjoy them every time. Smiley face. Some kind of timetable to see the next stream date would be nice. How?
Thank you for the 5 level user. Glad you're enjoying the streams. Timetable for now is every other day at 5 p.m. CEST. That's, I think, what I've been doing for the last couple, and that is the plan going forward from this one now. I don't know how much time I'm going to need in between streams from now on out when it comes to doing wiring or doing some other stuff that I don't want to have on camera because it might be boring. But yeah, 5 p.m. CST every other day, that is the plan. The TrueLinky, there are contact, well, not forms, but there are the best way if you want to send me something for testing, which, to be honest, I'm not sure if I'm going to have the time to test individual components. My video schedule is already so full. Is where is it? toms3.org/review-guidelines. That has basically everything on there that you need to know when it comes to sending me stuff for testing. And it's got all the, you know, hey, sending me a part for review does not mean I'm going to review it. It's got all those conditions, those terms and conditions on there, just so we're not getting like false hopes and false expectations. And also for everyone else watching, this is, you know, when I review stuff, that is, have a look through those terms or through those guidelines. Those I stick to for every single product I review, which is like, hey, you don't get to see the video before I publish it. If there are flaws, I'm going to point them out. I'm not accepting payment. All that is in there on that page for everyone to see, and that page also has the email address for, you know, getting in touch if you want to send stuff. So 1, 2, 3 heat sets in here. We need the one in the end of this little bit. Now it's going to be a tricky set to heat, heat to set. Will send me food if I review it. My mama told me not to take food from strangers. So there's those 3 done. So more heat sets. So that's the part that I said looks like an extruder part, and I was right. Ha! Ain't I smart? This is not the part that I'm looking for, but it looks like it. No, it's not. What are you then? Oh, that's okay. That's just the back. All right. All right, so let's go through them one by one. Let's start with this one right here. You go in here. Build the Voron, they said it'll be fun, they said. Or it'll be easy, they said. Nobody said this would be a quick stream or a quick build or anything. I was told it would be like 25 hours. And so far, I think I'm making, especially for being on stream, on camera for the entire build, I think I'm making pretty good progress. I'm pretty proud of myself there. And that, I don't think is getting a heat set. That is the filament path. Ow! Ha! That's hot. I guess you could put a heat set in there and then drill it out, and you'd have a... Or would you need to drill it out? You could put an M2 in there, drill it out, and you have like a metal filament guide in the filament path. Why don't you stand up? There we go. So 2 more in the back. We did the one on the side, 2 more in the back. So on the very outside edges. Keep it really fast, even for a first, or especially for the first Voron. Well, I've built a printer before. It's not like this is my first rodeo. It's my first build of a Voron, but ooh, that one's crooked. I like to think that I'm familiar with the basic concepts of building a printer. All right. Yeah, that's straight enough. This should be sized for a Bowden tube. Okay. Let me see. There should be some PTFE included. I thought we needed some longer bits. I thought the printer would eventually need some longer bits, so let's see if this fits. Well, yeah. But it does grip onto it pretty well. I'm guessing it should go pretty far down. Okay, because there is like a little visor slot. Oh, come on, lighting, help me. There, that slot right there. I guess that is to. Oh yeah, no, on the bottom as well. That is to indicate like how far you've pushed the filament, or not the filament, the Bowden tube in. So that's going to be a bit of a tight fit. Oh yeah, you're right. You're right. That is just to visibly see if the filament is in, because the Bowden tube doesn't go in that far. That's going to be a bit of a tight fit, but we're going to make that work with the correct piece of Bowden tube. Will this be your first Clipper experience as well? No, it will not be. I know it's blasphemy, but this printer is not going to run Clipper. I'm sorry. It's going to run RepRap firmware on a Do-It 3. Oh, I said. Okay. Drive pinion. So we need some extruder parts here, I guess. We're going to need this fan at some point. Where'd I put your... What am I stepping on? Oh, just an empty bag. We do have some extruder parts somewhere around here. Some pieces will come with you. Extruder pieces, drag chains. Oh, hold on. We have some screws included. Oh, we have some screws included. I just found some screws. In the pack from Slice Engineering, there are some screws included, and there's also a part cooling fan, which I don't think we're going to use. So they did include the screws. That's good. I guess that is part of the... That's not the pack that's supposed to be in there, but yeah, that is included with the mosquitoes. Where did I put my extruder parts? Oh, there they are. There they are. So they come in like a little plastic tray. So let's have a look at these extruder bits that we're getting here. So first thing I'm seeing is brass. And typically, when you see brass in a box intended for extruder parts, that is a big red flag going up. But this is just a brass actually a proper gear that meshes with this guy. So it has a, that's a lot. That is like 3-to-1 basically, and close to 3-to-1 gearing. This goes on the stepper motor. This goes on onto these Bondtech style drive gears, so Bondtech knockoffs. Essentially, oh, that's the one that's getting the bearing. This one gets clamped down onto here, and then we basically have I guess a Bondtech LGX knockoff, sort of, or I guess the Himera is basically the same concept as well, with a pancake motor, with a relatively small pancake style motor, and a gearing step first with like industrial or injection molded or proper gears that are not 3D printed. And then you have your dual drive setup. Basically, BMG extruder repackaged for the afterburner form factor. Yep. That's what it... That motor just made a funny noise. That's what it looks like. And then there's a little a tension adjustment screw. Oh, why are you sticky? Don't you love it when you have fresh parts that are already sticky? Right, there's 2 tiny bearings included. I have no idea how long these are going to last, but look at that. These are minuscule. There's my finger for scale. Yeah, and then those little roller bearings for the idle side of the dual drive gears. Loop those up. Where's the axle of the tension idler? There it is. There's that. So that's what the these 2 roller bearings are going to run on. Inside the idler side, so these 2 bearings are going in here, like that, and that's going to ride on that axle. Okay, so let's try and assemble this at least oriented correctly. Now, one thing to note is this motor has a wire attached to it. This is like 40 centimeters or something, 40, 45. And I would prefer these not to have any wires on them. I would prefer to have these with the regular connectors, just because it makes wiring easier. You're not going to get this down to the board. You're not going to run this wire in a drag chain, at least you shouldn't, though this feels fairly soft. So what you're going to have to do is, or what I'm going to have to do as well, is to cut these off at like 5 or 6 centimeters, put a little Microfit Junior connector on it, and then put a Microfit Junior connector on the wiring loom as well, which is already on there, and just have like an extra connector right there instead of being able to plug in straight into the motor. So yeah, that's going to be a crimping job in the future that I see coming up. Right, but I'll try to match the wiring direction as well. So this is, hold on. Driver pinion spacing, 3.2 millimeters. That is oddly specific. Okay, so I guess there's not a lot of space in this entire extruder assembly. So let's try and do 3.2 millimeters with the set screw going away from the motor, and that's going to get some thread lock on as well. There we go. So we need a little 1.5 mil. That's you. Oh, that's an M3 set screw. Hate those. Thread lock. RF equals Marlin. No, RepRap firmware is the firmware that is made by the guys who make the Duet boards. So that's, I mean, it's a firmware that can run on, I think, on more than just the Duet boards, but it is, well, that set screw is rather short as well. Do I have one that's better? Yeah, but it is kind of specifically made for, yeah, that's too long though. It's kind of specifically made for the Duet boards, at least made by the same team. So of course it's going to have the optimizations for that in there first. Now, how do I space out 3.2 millimeters? I guess I'll just use a screw kind of as an optical indicator, and I sight this down side. That's going to be the closest to 3.2 millimeters that I'll get. If I put another one in the back, yeah, these screws are 3 millimeters, so if I go slightly above that, okay, this is like an open sight that I'm using these like, but just for height. There we go. So that should be good enough. That should be aligned well enough, and numbers from the CAD just needs to be close. Well, I mean, the thing is, if it's like 3.2 millimeters, if you're giving me, you know, 1/10 of a millimeter as the spec, like I'm going to try to stick to that as closely as possible. Measure the height from the central part. I still don't have my calipers down here. I would need to get those, but yeah, I think that is close enough. Might be, yeah, as Nero was saying, it might be a bit over. Yeah, it's fine. It's fine. It's fine, really. So you're on here, then make sure to orient the motor on the drive plate so that the wires are on the left side. This will allow you to correct routing to the cable cover that will be installed later. Hey, and welcome Thomas as a YouTube member. That is much appreciated. YouTube members, by the way, monthly hangouts, roughly monthly hangouts, with your questions answered, kind of like, or exactly the same as the equal patron tier. If you want to join in on it as well, yeah, there's the join channel or become a member button below. So this goes with this little cutout towards the wiring side. So it goes on like that. And I think we start out with one single screw. Yeah. Adjustable motor position. Okay. Is adjustable to allow for properly meshing of the drive gears. You start in the topmost position of the slot, but check this cord. Check this cord. Yeah, that's the kind of the standard wording in the manual. Check this cord if you have any issues. So this is a bit of a, yeah, this one has a just tiniest amount of adjustability, and we need an M3x8 for this. Such clean prints. Yeah, they are from the Voron printed forward team. What's the wait list like for those right now? Last I checked, there was like 104 prints still needed to be done. So if you applied for a printed forward parts kit, at that time there would be 104 kits to be printed before yours would be done. So I'm not sure what that is like right now. 11 months? Wow. Like I said, if this works out, and if the add-on I'm building for this printer, which would allow to print stuff continuously, works out, I'm seriously considering joining Printed Forward as well, because it's insane. Waiting 11 months for your parts that's rough. That's worse than a Prusa Mini. M3x8. So I'm not going to tighten this one down all the way yet. Check placement. Ensure that the filament drive gear is fully seated against the drive gear shaft. Okay, so that goes on all the way. So no, that's the idler side. We don't need you. You with the gear all the way against that gear. By the way, using a bit like this kind of helps you not strip not strip the thread or strip the. It's as close as I can get. Not strip the 1.5 millimeter hex key or hex slot. What is this called? The mate that this key goes into. Because these are pretty easy to damage. And again, I do prefer just M4 set screws because they are so much harder to mess up. And this is, wow, that's especially rough because this is like a 2 millimeter length screw, so it doesn't even sit straight on my key here. So it only starts to straighten out once I get the thread started here. Wow. So you need to sit all the way against the gear. We're already zoomed in, but these parts are pretty tiny. There you go. Take that off, just to make sure we're not getting any thread lock in our gearing. That would be unnecessary. Ego's chains are like mid-August as well. Wow. The supply chains are a mess right now. Apparently for everything. So I mean it's great that you can get these parts at all. But like, don't know if that's gonna get better though as more and more people build Vorons and just the printer series gets more and more exposure. Ha! Tricked you, autofocus. Tried to focus on my hand. Got you on the gear. Check clearance. Make sure the drive shaft is not rubbing on the extruder motor. You can sand the face of the drive shaft if required. Alright, so we need you. Okay, so there is the tiniest lip in this bearing seat. There's a little tiny lip in the back. So if I get you in here. Make sure it's not rubbing on the... How would I check that? I can't exactly see in there. Okay, so what I'm seeing... Oh, this might be really hard to show. So in the center of that bearing, you can see a bit of a pin, or a pinhole. That is from this shaft that is turned down with the tool slightly off center. So there's just a tiniest little nub sticking out the center of that shaft. Honestly, I don't think that's an issue, especially because it's in the center. It's in the very center, so that's not going to cause any friction at all. Is it because it would be offset? Oh, worst case, it would be 0.5 millimeter. So, yeah, that's. I'm going to say that's not an issue. It still does run fine. Right. So we did check the clearance. Clearance is non-existent, and basically now it's just. Hold on. Where does the idler shaft go? Idler shaft appears. Oh, did we skip that? Nope, the idler shaft just appeared. Drive pinion. Yeah, there it is. No, hold on. That's the gear. Hold on. Now we've got the idler shaft. Okay. So why are we putting this on? We need to put the drive shaft in, or the idler shaft in a second anyways, right? Oh no, that goes into, okay, that goes into an idler arm that's assembled from the side. All right, my brain's not working well. So this basically gets assembled completely at this point with some 3x30s. Yeah. So 3x30s. Thankfully, I have like half of the Voron dev team kind of keeping tabs on me. So I mean, so far I don't think I've managed to mess up badly. Are the PIV parts done with ironing is what N is asking. No, they are not. As far as I can tell, so there is the printed forward parts. Maybe it can get you a bit of a reflection. It is a very smooth top layer, but it's not ironed. Mine are done with, so the my extruder parts are done with ironing, but I think that was more of a detriment to the where are we at? That's more of a detriment to the fit of the parts than anything. So where do you go? How do you? Is that even the right part? Yes, it is. Oh, okay. So that obviously this side, this slot that I just showed, that's not going to be visible, so you don't get to check the filament. All right. So this goes on like so. No. How does this go on? Like so. Okay, I had it backwards. It goes on like this. There's in a lot of these parts, there's like little lips that line up, or little parts that kind of join up. Not sure if these have like any functional value, but they're there for alignment, and they tell you, okay, you've assembled it correctly when just all the parts line up. So the bearing's pressed in. Do we screw these together? Okay. We do. So one of these sides gets an M3x30. The other side gets an M3x30 as well, but this one gets that little hook latched onto that screw, I guess. Somehow? Why are you swiveling? Where did that part go? Where is this part going? We put a heat set in it, so it's part of the printer. Where did he go? So supposedly this part goes in there somewhere. It disappears inside the body. Push it. All right, I'll try and push it. So the manual says something like this, and then you push it. Push it in. Where are you going? But this isn't. How far? Oh. So like that? I do not understand. So I guess the and it does look like this wraps around the drive gear, but like is it supposed to fit in like that? No, yes, yes, no, yes. It's held in there by the latch. You missed the top lever. So the top, okay. I'm guessing something like this then in the end. And that's what that would screw in, but something, oh, so, okay, so this guy still goes in. And then you go in like that. Okay. Now this makes sense. Okay, because now that part is being held in place. So that's in place. But we do need this extra part, which the manual has not mentioned yet, to keep that part in place. Okay. Just leave it in there for now. Okay, if it doesn't fall out on itself, I'll leave it in there. Whoops, it fell out. So that side I don't think needs to be tensioned down. Well, I guess it should. Should both get tensioned down pretty well. Don't drop these bearings, because you need both. You have the updated version of the clockwork. The manual still has the older version. Yeah, that's one thing that I'm noticing quite a couple of times, that the manual is in need of updating. But we will manage. Do these bearings need some grease? I feel like they do because they're completely dry. And dry bearings do run well, but come on. Okay, so loop these up. What is that noise in the house right now? Like the dogs are howling. I'm gonna get some lube. I'm gonna get some high temperature lubrication. 1 second, please. Okay, quick check on the dogs. I guess my dog Bella was howling. She likes to do that when the phone rings. So that tells me that probably the phone rang. Oh well. Dogs are the best. So we've got some grease in a box, in a pot. I don't think I'm even going to need much of this. This is some fairly cheap high temperature grease, bearing grease. Should be the right stuff. And I always keep a little brush right next to that, just so I have something to apply it with. So basically now, comes back with a can of WD-40. No, I would never use WD-40 for this stuff like this. Never. And you shouldn't either. So basically just you get some grease. That should be good. All greased up. And that's that's gonna be tricky without getting grease all over my finger. Too late. Fingers. Too late. Push it in there. Do I have a label on my label maker that says label maker? I might have. And then you go in there like this. And I guess this clicks in place? Yeah, it does. Okay. That is well greased up. I do like a good application of some proper lube. Like that usually makes stuff, you know, just doesn't wear stuff out as quickly. It makes it run smoother. Yeah. Totally works. And yeah, thick grease, even though I'm told it's not the best for like linear bearings where you have the recirculating balls. Oops. For actual bearings, it is very, very good. Will this grease make PC parts crack? I do not know. Might be something to experiment with though. All right. Let's keep moving. So, lubrication. Oh, it even says so. All right. Idler goes on with another M3 by 30. Where are you? M3 by 30. Though these parts are all ABS, and I think ABS should be less sensitive to this sort of stuff. Okay. So you go in there, you go in there, and that screw is then gonna go through that. So I guess you need to go in here. Can I attach this yet? Guess I should attach it later. So you go through. Okay, there's a threading in there. That's fine. So that's pretty tight. That's what we have power tools for. That feels about right. Right. Oh, and we need a spring. Yeah, sure. That's in. M3 by 20. It's here. And you go in there just enough. So the hingy bit is in there, the tensiony bit is in there, though that I guess needs to go through here. Yep, that's hooked on, and then that gets locked in place with the latchy lock, and the spring's gonna go on the idler in a second here. Too much. Oh yeah, it does latch down. Okay. So that was not too much. That was not too much. Okay. So that goes. Oh, but no, this guy. There we go. Ooh, that's tight. Spring on here. Screw it in there. Less torque clutch. It's already on the lowest setting, and then this should just go. Do I have the... so the little latch part might have jumped out for some reason. I guess the... Or the... what's it called? The part that... Come on. The part that holds the tensioner screw in place. So you need to go further back, and then we can reinsert you. Nope, the way around. We can reinsert you. Alright, and you can go back in. And that should be a functioning extruder. That should be a functional extruder overall. So there's your tension adjustment. So this is an unlock, lock, unlock. It does latch onto that little hook. Okay. All right. That hook is basically butted up against the idler. Could it be part of the idler? No, it can't be part of the idler because this hook against the idler, this is what's giving you that that spring tension. I'm having a hard time showing this. This is what's giving you that spring tension for actually tensioning against the filament. Basically, that gets pushed in, and this gets clamped down, and that flushes up the eject lever with your idler. Theoretically. But it needs to go in all the way. Okay, so now it's locked. Do you need to loop the outer teeth of the bond gears? Probably not super necessary, though I could do that. Now, you can always still get in there. Looping up those teeth, however, it is pretty close to the actual drive section of the drive gears, so I'm not sure if that would be an issue at some point. Okay. Bond gears aren't meshed. How would I know? So yeah, I guess if it's like that, it's like that. It's not meshed, it's not in all the way, so this wouldn't drive filament as it's still coming out. But when it's in like that, that would get them meshed, I think. You have the teeth of your gearing in there. And this does feel smooth. And this feels like there's nothing binding or grabbing or causing any other issues. This does feel very smooth. Now, would this need to be lubed? I don't know. That's a palm gear, as far as I can tell, or a nylon gear, and that typically is self-lubricating, and there shouldn't be like super high forces on it. It's a tiny stepper. You need to tighten it more. Well, yeah, I mean, you can tighten that more with the adjustment screw at some point. Okay, but that is the extruder done, I would say. A little more bits of drag chain holder that we still have. There is that. Screen cap. Let's see what's next. Plastic washer is gone. Remove the plastic washer. Yeah, there is still a plastic washer. Where is that plastic washer going? Plastic washer. Whoa, between the printed part and the spring. Oh, okay. All right, well, if it's just in there, that's like... If we're rubbing against the plastic washer or a plastic printed part, like, that shouldn't make a difference. I guess somewhere there then, but... Like, sorry. Remove the screws, what? We're taking apart the stepper motor? Wow. Okay, I guess. I did not expect that. I did not expect that we're taking apart the stepper motor today. So these two are going to need to come out. And these are regular Phillips. So the ones around the, next to the drive gear or the gearing gear. Gearing gear? Aren't all gears gearing gears? I mean, I guess you can use this thing as just a screwdriver. If you need to. Her taking apart steppers is unsafe, is that true? I don't know. I'm not sure how much you would damage them. I've taken apart steppers in the past and they still work. Actually, they don't still work fine. They feel like they're like if you've ever taken apart a stepper, it has its rotor with like those little teeth, these little notches, and it has the stator outside of it, which has kind of the same style of teeth meshing into that or not meshing into that, ideally with a thin air gap around it. And it feels like after I had taken apart that stepper and reassembled it, it feels like sometimes they would catch and the stepper would get mechanically stalled by the stator meshing into the rotor. So there might be some truth to it. Not because you're like letting the magnetism escape or whatever. It's because you wouldn't be able to reassemble it as precisely again as the factory did. I think that's what's causing that. But yeah, taking out 2 screws should be fine, as Christoph is pointing out. So what, Jeff? Your name is Jeff. What is up with Jeff? Anyways, moving on. We've got two screws removed. We are going to be replacing these in further steps. Oh, I think there's the further step to replacing them. What are you? Make sure you look at the next 2 pages of the manual. The sequencing gets weird on the next part. Okay. So what are we up for? So we've got the guide or the mount for the drag chain. That looks like a wire cover. Yep, that's accent colored printed. This little, I think that's a wire cover. And that also looks like it might, but it's just barely not going over the stepper holes. But it is, okay. And then, so there's 1 screw going into, okay, that's the threaded insert that we put in earlier. So basically, oh, that part just snaps over the screw heads. Over, not under. Simply hangs off the heads of the M3x20s. And then there's the one M3x8 that actually holds it in place. Interesting. So M3x20. M3x20 going this into the stepper motor directly, so like that. And there's like little sticky outy bits that actually go into the detents or the cutaway bits on the backplate of the stepper. M3x20. Where art thou? Why am I looking for this for the same screws every single time? Like every time I need a screw, I'm seeing all the screws but the one that I actually need. Is that like something you guys are seeing too when you're building something? You always find all the parts except the ones that you're actually trying to find? I feel like 20, those feel long. But I guess, yeah, that's about the right length then. There we go. Just the right amount of torque. And then basically we have, so you go out the back and then this just latches over those two screws. And yeah, I can see the spacing is ever so slightly off on these. So the spacing on the red accent part is a bit tighter, a bit closer together than on the screws. So you actually have to push it over and it's held in place by pushing apart that red piece a bit. I don't know if that is intentional, but it sure feels intentional. That's one extra M3 by 80, M3 by 8 that holds that cover in place or secures in place. And that is actually enough space. That is like plenty of space in there. Like you can see how much of a canopy that's spanning up to have, for example, the Molex Microfit Junior connectors for the extruder motor that adapt this thing to the wiring loom that I have. Motor wire goes out the rear. Here's the thing, when you guys say front and rear, I still kind of don't know what you're referring to with front and rear. Like, I would think this would be the front because it has Voron design logo on it, but could also be the back. This goes out the back. Take the screw out. Ah! There we go. Now it's out the, what I guess is the back. Steppers on the rear, yeah, makes sense. So that's done. M3 by 8, that's on there. Okay, that, ooh, why is there a style change? Can you see that? Like, this is very fine line. And all of a sudden we're like, oh yeah, you're seeing me now. You're seeing the outlines now. So this gets mounted to, let me see, to what? Not to the tool head yet. Just double checking that there's, nope. So that gets mounted to the tool head in a second with a couple of screws. But we're basically, okay. So we need a hard cooling fan. That's the one up top here. We need a hot end cooling fan. That's the one down there. And then our extruder gets attached to the X carriage. And then the fan assembly gets attached on top of the extruder. All right. Okay, updated parts with a different style. Yeah, because the style, I don't know, slightly changes. Okay, so fans, fan shrouds. We're finally using the part from the thumbnail. The one with the big Voron label on there that does look kind of suspicious. You and I think I already grabbed the radial fan that's actually going to sit in that part. So you go in here. So you go in here. You don't go in here? You just, oh, okay. So you just sit up against that and look like you go in here. So that might be a bit of a mismatch between what the printed part is designed for and what... Oh, because that is absolutely not going in there. A bit of a mismatch between what the printed part is designed for and what the kit actually supplied. Because that does not fit, and I don't think the other way around would fit either. Ha! Take the front off and read the manual. That's the manual. That's all the manual says. The manual literally doesn't say anything about that. The manual isn't correct. Is there a newer... Use the link from the previous message. Okay. So this is a manual that I did download when I started the build. Which is... Oh. How am I going to get that from the USB drive? Hold on. That's going to be a second. Because I do have this one computer running the entire stream in OBS and all that, and I've got the other computer just showing the manual. So let me just save that on here real quick. And then we're going to have an updated manual. Okay, I downloaded the correct one, but is that a spare USB drive or is that something else I'm trying to jam that into? Okay. Right. Now, how does this work in Windows? Like that? Oh yeah, update. How do I get into Explorer without a keyboard? Like that? Is that the Explorer? Yeah! Oh look, I still had the parts from the PR 61 and the FT52 build on there. Updated manual. So that is version 2001.1.20. Look at all the stuff we've already built. Oops, there it was. Like it feels like it's a oh, there we go. Feels like we've already done so much in the build. Now, how do I get into full screen without pressing F11? I might need to flip this guy over real quick. No, hold on. Is there an F11 on the keyboard? Nah. Okay, I'll flip. Next to zoom. Hold on. There it is. Okay. Perfect. Convertibles. They're fun. No, Windows is surprisingly well optimized for use on a touchscreen only device, but then again, if you're not used to using it on a touchscreen only device, it's like it's rough at times. It's not super intuitive. So where are we at? So we did that. Oh, and there's more details on how everything's supposed to latch together. Okay, that would have been helpful. Separate blower housing, and then there's some filament that goes in there. Okay, I would have missed that as well. Yeah, that we can see that on this one. Barely. Guess if we use, what's the other part that goes along with that? Not this one, this one. So yeah, there's also a hole through here that goes like this, I would say, yeah. Then it's just connected with some filament. follow page 72 from that manual revision and continue with yours afterwards. Okay, so I'm not going to be doing anything from this then. All right. Okay, so we need to separate the blower housing. This is an older manual. The pages you're working on now went missing during a recent update. Okay. Separate blower housings. This one basically just snaps off. Like so. Now we're left with the spare fan cage. And then we insert you in here. Okay, that works out. So now we have that vacuum intake shroud exposed here. Okay, that works out. Is there... I'm just going to need to figure out how this gets mounted, but we'll do that with the other manual. And then we need some filament. We need some filament. Is there... I don't think there's filament included in the kit. No. So filament. Let me grab some filament then. What are you? No, you're PTG. Actually, PTG should work, even though these are ABS parts. Can we use some flexible? PLA, ASA. Well, it's still sealed. I'll just use some PTG. That should be alright. Actually, I think the one with the section with the gears or with the gearing from the extruder on it should work as well. How loud are these fans compared to Noctuas? No idea, I haven't run them yet. But typically, fan noise is mostly proportional to fan performance. So, yeah. If you use a Noctua fan, you will need to have everything else optimized for that Noctua fan as well, or you might run into issues with part cooling. Interesting. Okay, so we've done that. Now it is time. Now that's the save. Downloads. That's the assembly manual that I've got. Come on. That is version 2021-05-20. So this is the new one. That unfortunately has the page missing for the fans and stuff. Oh, we're way past. Hold on. There we go. Okay. So we've done that. Actually, is that page 79? No, so the page number is not missing. It's just that the content is missing. M3x16, M3x30, M3x30, M3x20. Let's do these in order. M3x16. The larger the fan, the lower the RPM, you can run it faster for equal air throughput. Yeah, that works for that works up to a point. That works for a point, but not really universally. So you, and then we have another part. We have you, I think. Maybe? No? That's like the only part that would fit, though mine looks slightly different. No, mine does not look slightly different. There is that notch I was looking for this notch on the side here, and it's there. It's there. It's right there. So you go on like so. But we need to have the fan in there. Like so. And the question is, where does the wire go? Basically, we can insert it into that side first, and it does fit pretty well. Wire goes somewhere. I guess I should release it from the back, from the strain relief. Okay, and then, yeah, I guess that comes out on the side here. And now this all gets screwed together. So 2 in the top. Main wires come out the back. Okay, 2 in the top. That is the M3x16s. Are these 16s? Yes, they are. 1 up top. And this is threading into plastic, so I'm going to be quite careful. I'm not going to use the power tool because we have very little plastic to thread into. And if we over thread it into plastic, like that's the end of that story. Just looking for the gap to close on the side here between the red and the black part, and yeah, that's going to be enough. That's going to be way enough. Still got the PETG poking through. So that's that. That's the top fan assembled. Now there are 2 more screws going through from the front to the back. That's 2 M3x30s, though I don't think those thread into anything yet. Those are going to thread into whatever we mount this to. So that's those 2 right there. Those just barely stick out, but of course once we're going to need those in a second. Those stick through the slightest amount. And then next we have our extruder that mounts to our X carriage. Okay. So that took me a minute. So we're setting this part aside again. You go away for now. And we jump back to our XY gantry. Oh, there's one more fan. Oh, I guess I could put this one in as well. So you here. Are you supposed to clip in? So something snapped into place, but not. There we go. If you lift it into place, or if you tilt it into place from the top starting out, and then that's going to work. And then this wire is going to go up through here, I would think. It comes out the side over there. Ah! Like this, I guess. That looks like it's routed. So the wires exit up top. Well, it's as top as it gets. It's like at a 45. So would 1 over actually be better? I can even get this out. Hoping I'm not going to snap this off. No, that's not coming out. That is not coming out. Nope. Well, I guess that's just the way that these are going to be routed. I see. Okay, it could get routed out that little bit on the side here, so it could get routed out right there. Oh well, that's in there. At least it's not going to rattle around. But now we have an M3x30 and an M3x20 that attaches it to the extruder body. It's two M330s. We're going to need those in a second. M3x30, M3x20. Where art thou? There you are. So there's a 30, there's a 20. There's another 30. So let me see if I can figure this out. There is some dovetail magic happening here somehow. So we've got two parts. That look like they should mate together here somehow, but I don't think they do. Instead, they mate together like this. Right, okay, because that is not dovetails, that is actually the air guides for the part cooling fan, which bypasses the hot end cooling fan. So you go on here like that. And then it's a 20 and a 30 going through where? Am I? Oh, it's going through the no. Okay, so we're first mounting the extruder to the carriage, and then we're mounting everything else together. I guess. So you go on the side for now, and then XY carriage first. The extruder goes on here. I guess there's only one way for this to go on because there's interesting. There's also a bit of keying going on for these parts to actually mate together in a very specific way. Right, and then the right one's getting an M3x20, which is this one. And then the left one's getting an M3x30. Okay. Remove the wiring cover for now. But I just put that on. Okay. So there is our toolhead. It is starting to take shape. Like, look at that. It is starting to become quite a long boy. We're gonna have the fans on top here, but yeah, with the extra long fan shroud. Whew. Wow. So we got that. We got two of the M3x30s going to poke them through the fan shroud, and now the fan shroud goes onto the extruder. Okay. You 2 and 3 by 30s. And then somehow. So I really need to rotate the hot end fan or the wires will break. Okay. I'm gonna try and rotate this. So all right. Didn't sound good, but made it out. I was afraid something would break, but thankfully nothing did. So that is now in at least a bit more nicely. And then there's a little wiring shroud here. There you go. And you go out the side here, you go out the side here, and theoretically this just goes on like so. Just onto the toolhead. Should actually put it into forward. Just to get something happening. And then this part, this hot and cooling fan is still kind of wobbly. Of course, this doesn't have a hot end in there yet. I'm gonna put the hot end in there at a later date. M3 by 12. Fake Sunon spec, or fake Sunon fans. I was told these are like the China spec. So they may not be available on the international market, but they may be a genuine Sunon fan, just of a lower quality. So hinge, you can trim the extra filament. Oh, now the extra filament is actually caught. That was something that we didn't have before. Before this was just entirely loose. Here we go. No more catfish look. And there is I guess the most characteristic part of the Voron installed. It's afterburner fan shroud deluxe with all the accent pieces, the latching extruder. It should be able to come out. All that. It's starting to look like a printer. At least the base of a printer. Right. Next. Wait, we're doing the cable shroud again? Next, I guess we're actually getting these into what are we doing? Belting Z drive. So let me just figure out what's happening here. We've got what looks like belt clamps. Let me see. So that's the idlers up top. Oh yeah, by the way, I wanted to show that. Ha. Bowden tube, yeah, that's gonna go in later. The angry Z idlers, that is what the Voron team sent me. That's where that idea of the angry Z-axis idlers came from. And they do have the eyebrows. We already have the angry eyebrows there, so yeah. That's what those are, and it looks like actually in the manual they don't have the eyebrows yet. Interesting. So belting the Z drive. Each Z axis is going to get its own belt. Now, what are you? Z joints. That appears to be an adapter where the carriage on the linear rail goes on here. And then what does that attach to though? Those make no sense at all. Hold on. So at which point, what are we doing? Belt routing. That's what the belt routing is going to end up like. So basically this is, what is this? This is what we have on our XY gantry already. So that is these parts up here. That's these bits up here, including the belt tensioners. So that is the belt tensioners on here, and the Z belts get clamped onto, okay. So they get clamped onto these blocks on here that we already have on the XY gantry. To not over tighten the Z joints, they're supposed to have some give to them. All right. So what is this then? Why is the belt running through on this one? That makes no sense at all to me. Because it should be clamped like this. Why is that image in there? Alright, mounting blocks to Z carriages. Just trying to figure out what we're starting with here. So these go on the bottom there somehow. And all of a sudden we have the LCD screen. Whew, that's getting mighty thin. Those instructions are getting mighty thin. Yeah, there's also no... Yeah, that's the attaching it to the XY gantry. Alright, let's just go through step by step. So step number 1 is assembling the Z, what's called a Z joint here. That's most of these parts here. So, no, yes. So these are going to be 4 mostly identical parts. 1, 2, 3, 4. And you we're not going to need, though there are some belt clamps that look like they're going to come in handy at some point. That's these. These are the blocks that attach to the carriages. 1, 2, 3, 4. These are parts I have no idea what they do, but they... What do these do? Have some belt clamping to them. Oh, these are the... Okay, these are the extruder parts. Right, these are the extruder parts that we didn't need, so... these are obsolete, so we're basically left with just a couple of parts, and this is also one that we do not need. These we need in the previous step, so just a couple of printed parts left. And you are the block that is attaching the bottom rail to the X carriage, which we did not use. So let's double check. We have that top block, we have that, and we have that bottom block, and we have our belt, what looks like belt clamps. So I'm not sure if they are belt. They, oh yeah, they go on the bottom. That's where they clamp. So M5 hex nut. So we're basically going to build 4 of these. M5 by 40. 4 of them, and then 4 M3 by 30s. And that plastic washer we don't exactly need, because that's a part of the extruder that we did not use. and M3x30s. This is the only really confusing part of the build. The M5 that holds the joints together also clamps the belts down. Okay. And then these bits have a cutout for an M5 nut. That's going in here. To be honest, I mean, the manual is still better than the manual that I got with some of the Chinese printers. So, yeah, and those Chinese printers cost money, and this is an open source design that, you know, nobody's charging for. So I can give that a bit of slack. Okay, so this is interesting. So I was wondering why these parts had like a ball joint surface on the bottom of them. These also have sort of a ball joint on the other direction, so these go together like so. And I guess the idea is that allows it to kind of self-adjust ever so slightly. Don't power tool these M5s. The M5 nuts will spin otherwise. What if I set it to the lowest torque though? What if I leave this on the very lowest torque setting? Is there an there is an orientation to these, and that is with, yeah, with the side that has the little cutout, the little bit there facing the surface that mates with the carriage. So no power tools, just putting it in here by hand then. So I was reading these are supposed to have a bit of slack to them. So I'm gonna leave them with a bit of slack. I mean, there's not a lot of rotational freedom there. There's like, that's like 2 or 3 millimeters or something. But I guess that should take up any sort of like tolerance and misalignment or something. So repeat that. Couple more times. Now, what does the M3 screw do? Manual still calls for an M3x30, and I guess that is a locking screw in that case then. Oh, what? No, hold on. What am I doing? What am I doing? I'm missing 2 screws. Okay. I'm missing 2 screws. I'm missing 2 screws in this bit right here. So I've got the screw, I've got this, that's the next step. So there's a screw going in here. I'm not going to be able to tighten that down. Hold on. So there are 2 screws captured in this upper piece, and they thread into something. So we're not assembling, I guess we shouldn't assemble this bottom piece yet, because otherwise we're not going to be able to get to those screws at all. I guess that's just for visualization later. Okay, so that's where that clamps a belt onto an XY gantry in the frame. Yeah, I'm seeing your chat.
Enjoy an adult beverage after the stream.
So I guess hold on. So the order of operation I'm thinking of right now is attaching these bottom blocks to the carriages, to the Z carriages first. Then attaching these upper blocks to the XY gantry and clamping the belt next, because these top clamps are separate. These bottom ones we can clamp, and then once we've got the top parts clamped to the XY gantry, we can set the XY gantry onto the bottom blocks, and we can use that long M5 screw that I just assembled, and I don't think I should assemble at this point. This one. We can use that to attach everything together. Whew! Okay, that's quite the brain tease to figure out. But I think that should work. I think that should give us a way to assemble these. Now, all I need are my M5 by something screws. There you go, my M5 by 30s. Tie everything together. So, you, and you. We'll save you for later. Come on. You, I have no idea where you're going. You're going on the bottom of these, so we will need you now. We also need the M5 by 30s now. Yeah, there. And we do need the nut in there, so because that would be impossible to get in later. It would be easier if you attach the bottom part of the Z belts to the gantry and clamp, then all you have to do later is clamp the top part after routing the Z belts. Yep, I think that is exactly what I'm trying to do. That is the button head. These screws are going to fall out again anyways, so grab the gantry and flip it upside down. Sounds like a plan. Add the belts, make them flush with the other side of the gantry on the bottom, then run the M5 and M3 down. That is exactly what I'm planning on doing. Thank you for that, Jared. Jared CO1. So, gantry. Gantry. So the belts are going to run towards the inside. So towards the inside. Okay, so they're routed through these holes right there. One goes, no. Right, okay, so that hole is for the side of the belt that is not being clamped down, and then these, the belt goes up and away, and on the bottom, down and away. All right, whew. So you go like this. You go like this. And then you go up. And the other side has a little clamp piece on there, so we can do that separately. So you go on like this. This guy has the nut trapped in it, and then you go on with no... You need some T-nuts. So we're not going to be able to screw in anything if there are no T-nuts in these slots. However, this hole is occupied. So I was told not to occupy the hole on the other side. And we did leave this one free, but it's the exact same situation on the motor mounts versus up here. Did you square the gantry? I did do some squaring, though I'm thinking the squaring comes later. So this, I don't think is gonna work. Okay, I can get this one in. And now the question is, can I get another M5 T-nut in here as well? Probably not. Is there anything... Yeah, this is going to run around the frame, right? I'm not going to be able to have this stick out on that side. So, nope, that's going to push the M3 nut in. Oh no. There we go. So I guess this screw is going to have to move. Use a hammerhead M5. That's actually not too bad of an idea. So let's grab a hammerhead. Thankfully, we do have some of these here. 2020 M5. Oh, I also have, but these are probably. Oh, hold on, these are perfect. So I've got my box of 2020 M5, and I've got three diff. Hoping I'm not spilling these. We've got the classic hammerhead, which sucked. Well, there's a spring-loaded one there. We've got the flow-drilled ones, and we have these. So these just slide in, kind of like the, what are they called? Peanuts, but these are much shorter than the M5 peanuts. I can maybe like that. Come on. So these are a lot shorter. They have the hole in the center, and you can only slide them in from the side on the aluminum profile, but. Oh, nice. Nice. Does not stick out. That is actually my second favorite type of nut for these rails. For these aluminum. I keep calling them rails, but they're aluminum extrusions. Aluminium extrusions, if you want to do that. So we have an M3 M3 T-nut in there. We have an M5, whatever those are called, nut in there. We need the belt clamp. We need the we need the nut to not fall out, please. Ah. Need the belt. This is definitely the trickiest part. Now just 4 more times. I've almost got it. Thanks for the tip, Samuel. Just at the right moment. That's a 3. Okay, that's the right one. Okay, are you guys saying like, hey, if I'm saying this is the trickiest part, I don't know what's to come? Yeah, belt is attached. The block is on there. Okay, this is basically flush. Make sure you have some spare belt. Well, yeah, that's the plan for now, just to leave everything with a bit of slack. So now just rinse and repeat 3 more times, as we've done a couple times already, right? Can't be that hard. So M3. So this one thankfully has plenty of space, so we can slide this in with this orientation. And I think we would even be able to use an M5. Come on, stay in focus, please. We could even use the M5 spring-loaded T-nut there. So, can we do that? Because, oh, how did I push this in so far? How did I push this in so far? Wow. Well, that's going to be a pain to get out. So it's now aligned with the hole in the linear rail. So when you're trying to move stuff like this, just use something that is pointy or at least has a sharp edge, such as a Allen key or a hex key. Next belt. Is the Bosch powerful enough? Would you recommend anything more powerful? The Bosch is plenty powerful for this sort of stuff. I think if you do max torque, you would probably rip out most of the most of the threads that we're screwing into. It's got like 6 Newton meters what it's rated at, and that's plenty. Have I already put the linear rail housing onto the rail, as in the little printed piece, or the actual carriage? The carriage comes pre-installed. Oh, hold on, we could actually do this differently. The carriage comes pre-installed on the rail. Okay, if we do that, come on. Ah! So if you get the nut in there first, get the screws in, get the printed part over it, get the belt on there, and then get this entire stack smooshed on there. Yeah, that's a bit easier to get to hold it in place. And then the M3. Flippity flop you around. And then this side, because the, come on, because this bottom hole is not used up, this does not have anything in it, I can put the M3 T-nut in it again with the long side facing the rail and kind of sliding in underneath there, like so. And then another spring-loaded M5 T-nut in that hole next to it, like this, with the long side facing inward so that it's not sticking out. Where's my belts? There's 2 of them. There they are. So, same thing again, belt goes in here, the nut is in here, it's captured, belt cover, belt, that goes on as a unit, belt is aligned, and we lock everything in place. What? Why are you not? What? Oh, I've got the wrong bit. Okay. That makes sense. I was like, I can see the screw is caught, but like, why are you not tightening down? There we go. And then one last belt on this one. Same procedure as every year. Bracket goes on here, and now here we have, yep. Oh, I was holding one of the belts in place. Here we have that same situation as on the other side, where there is a screw in the top hole of the rail. So we do need to use the shorter type of nut for the M5, and we can use the M3 with the ball detent, and align it in a way that it's pointing outwards towards the M5, like so. And then one last belt. Check the belt on that AB bearing stack. Yeah, it might have come off. Might have slipped off, but we're gonna double check all that once it goes into use and once we go to get to tensioning everything. Okay, so XY gantry assembled. XY gantry assembled. So you are basically ready to go onto the Z-axis in the frame. Basically, right? Yeah. So we're gonna park you back here. It's not quite an octopus, it's like a quadrupus at this point. So that's gonna make for an interesting perspective. But basically, on each of these rails, I'm gonna need one of, where are they? One of these blocks, M3 by 20s, goes on like so. And that's I guess, there we go. Goes on like so, and then the XY gantry just sits on top here, and we bolt this together, I guess. And 3 by 20. Let's just double check. M3 by 20. And then we're doing the screen, which we're not doing. And then once this is bolted in place, we still need to route the belt. So you, lowest torque, right bit. Basically, just a whole bunch of assembly. I'm going to leave out the M5 screws for now, because those are just going to fall out. Yeah, I guess you can assemble these with a bit of a tilt left and right, and that's what that ball head joint does. I wonder if the surface of that ball is actually lined up with some specific position, because if it's not, if this ball surface is not lined up with the source of your error, like for example in the center of this carriage, you might compensate for like a rotational error, but by compensating for that rotational error, you're going to start introducing a positional error instead. So I wonder if there's any like rhyme and reason to that. Actually, let me see. We can use these stoppers now and put these in a better position. Just gotta make sure that I'm not like pulling these off the rail. That's gonna give us access to, because now it's stopped in place right there. That's gonna give us access to actually assemble these. Actually, let's do this a bit higher. And like the 1, 2, 3, 4, fourth hole. So we're not gonna have to hold these in place the entire time. 1, 2, 3, 4. So a bunch of people have already said, hey, this is my my background noise for building my own Voron. Who else is building a boron a boron nitride printer? Who else is printing or building a Voron watching this? Because that's like, that seems to be a common theme with these build streams. People building the same printer while watching me build these. I find that kind of charming, just to, you know, the fact that this build might be maybe not inspiration, maybe not a guide or anything, but at least some entertainment for for you all building it at the same time. Wow, bunch of people. That's like a dozen folks right now. Wow. What are you guys doing? Are you guys doing kits as well, or is it all self-sourced these days? I feel like self-sourced is like the premium solution, and just the, you know, a kit is kind of the easy way out, more or less. Is a Voron ever really done? Self-sourced kit, dolly build guide as a guide. That's not going to give you a Voron. Lots of self-sourced. So I mean, for me, the reason the reason for going with a kit was basically time for the most part, and time as in spending the time to find all the parts and then waiting for them to arrive. And also it's like just finding all the individual bits. I mean, it's an experience. It's something that, you know, you do and you've experienced. But I've done that before and I was like, well, I don't need to do that again. I mean, what really are the specialized parts? I guess the extruder parts are kind of proprietary. I mean, if it's actually Bondtech parts, then that shouldn't be too hard. But well, we can actually do that. Self-sourced. Extruder parts are just BMG, so you buy a BMG basically. Oh, these belts are slipping off ever so slightly, but that shouldn't be much of an issue. Okay. Hanging with zip ties. No, we're good. Let's see. No kits out there. Yeah, that too. So this part with the cutout, that's the back, as far as I know. So now, with the extruder kind of looking at me, I should have the front facing me. Huh. Oh, wow. That is pretty far off. So on this side, we are off by about 2 millimeters, 3 millimeters in the back. So 3 millimeters off in the back and about 2 in the front. Actually, if we move you back. Same. So in the back here, this is the joint right there. So if I line it on the left side, there's about a 2 millimeter offset, which I don't think we're going to be... No, hold on. If I actually align this, this is like 3, 4... It's about the size of a screw head of an... It's a bit less than the screw head of an M3, which is 6 millimeter if I remember correctly, so like 5-ish. And then in the front right now with the x-axis in the back. Hello, camera. With the x-axis in the back, it is more like 3 millimeters, but the opposite direction. So how do we align this? That's why the back beam was loose. So basically what I'm thinking, the way this will be aligned is undo all the screws in the back, so these two, and the ones on the bottom. Undo these to allow it to kind of snap into place. Undo the x-axis screws as well to allow that to conform to that, and use that kind of as the reference. And transfer this to the front by moving the x-axis to the front of the machine. I'm not going to worry about belts right now, because the belts are like the least of my concerns, as long as the dimensions don't match up. So there's an exactly in chat. That's my sign to go ahead with this plan of mine. So you get loosened. You get loosened. Ha! You are blurry, but thankfully we can focus you. Oh, that's uncomfortable. You get loosened, and then same on the bottom. Put stoppers on the other end. Where on the top end, I'm not gonna, I mean... Where would the bearings go? I mean, this is, come on. I don't have anywhere to go. So if I pull this to the front, yeah, I can pull these apart. These actually get pulled apart quite far, quite a bit, and that also tensions the belt some. So I guess it would be a good call, a good time to switch to that perspective and actually tension these down. So I'm gonna undo the screws on the x-axis, on the x-beam. If I remember correctly, it's these. And then I think it's this one that's also clamping it down. Yeah. And that should allow that to kind of come apart. Yep. That does allow it to come apart. So the question is, if we tension this down now, that's going to conform our XY gantry to the dimensions of the frame at that height. And that's making the assumption that the frame is the exact dimension up top as it is at the bottom, but that is kind of taken care of by the fact that these are extrusions that are between our vertical extrusions. So if these extrusions need to be cut to the exact same dimensions of these and the ones going towards the front for this all to work. I hope that is the case. I mean, I think the extrusions were pretty good. Do we have that trap nut in there? I sure hope so. Yeah, I sure hope that that is the case, and I think the extrusions were all pretty good. So how do these get aligned front to back? So left to right is pretty easy, but front to back, where do these sit? Ah! I guess these are gonna just naturally find their position. Sam, what is up with you? I guess. Okay, and this side back here just gets pulled back. I mean, sure, people told me I'd loosen them, but the thing is, like, the XY gantry is impossible to build if everything is loose and slopping around. You would probably break stuff if this gantry was not at least somewhat tight while building it. Did I undo the front to back screws? No. So the front to back screws. I can't undo those. So hold on. The positioning of the... So the distance of this top piece sitting on this Y rail, and the position of this top piece sitting on this Y rail, is basically defined by the screws that are now hidden by this part. So I would need to, yeah, front to back. I have no way of aligning this front to back. So this piece can move back and forth if you undo the two screws that are hidden in this block. And I can only undo them when I don't have the carriage attached to it, which is kind of pointless. So front to back, I think, is just gonna... It's just gonna have to be... Yeah, so this was roughly flushed up with the end of this extrusion. That's just gonna have to... There's no way to adjust it. It is the way it is. So this gets pulled over and flushed up. No need to overcomplicate. Well, no need to overcomplicate is the little brother to, well, this thing is going south really quickly. So alignment issues with builds like this are a pain to figure out. So yeah, I would rather take a moment right now to thank all of you watching. Haha, no, I would rather take a moment right now to figure this out and make sure it's as well aligned as it gets. And that this is tightened down well enough, because it was moving just a second ago when I thought it was tight enough. Yeah, I would rather take the time now than have to deal with some mysterious issue of racking or whatever later. Hold on. So this one I shouldn't tighten down all the way yet, I think, because I'm going to put the screw in, because the x-axis is going to travel from back to front. So if I tighten this down now, I might get binding on the x-axis rail. Don't know if I tighten the Z-joints. Well, if they're moving, if I can feel them moving, they're going to introduce some wobble into the kinematics, because they're transferring the entire force, or the dynamic forces of the toolhead accelerating and decelerating. So they need to be slop-free to work. So the back ones are the bag Z joints. These guys on the side that we just tensioned down. These are aligned by feel, so I can feel they are aligned with the belt clamps. Oh, I'm just seeing I missed the belt by one tooth. So this guy sticking out one tooth. Oh well. These are aligned in the back, which means I can tighten down. I can tighten down the crossbar in the back. And I can tighten down with the x-axis pushed, or the x-bar pushed all the way back. I can tighten down the x-bar. So let's do that. And these all thread into metal, which means I can give them a fair amount of torque, unless I can't actually get to them. Can I tighten these down at an angle? I can. So I need to make sure to not push this up, or I'm going to push the Z-axis carriages off of the rails, which would be quite unfortunate. Come on. You, and then you go back here. And then the one in the bottom as well. But that's a... Nope. That's the same type. Then you are here. So that should be crossbar in position where it can stay. These are tightened down. The X bar is also tightened down, and the length of the X bar is now set. So the length of this is perfect for back here because we aligned it to everything else. So now move it forward, and that should give us the correct distance between the left and right Y bars. And yeah, as expected, this left Z joint feels like it's like a 0.5 millimeter off. Feels like this is 0.5 millimeter set further inward. So if I had aligned this the same way as I did the other ones, just making it flush, we would have put tension on these Y rails, because this X bar would have been too short for the position here. We aligned it in the back and then we move it forward, and these wouldn't be parallel essentially. But because we have the X bar tightened down now, that makes sure that the Y bars are parallel. Put the belts at the bottom first. You'll have 4 belts attached to the Gantry before you line it up. Right, so that means I get to tension down or tighten down this last one corner. Right, so do I have any M5 screws left that go into the... What's up with you? You are the... You're the belt tensioner? What are you? Yeah, you're just attaching the belt tensioners to the Y-axis, so that's fine. Oh yeah, belt tensioners as well as the Z belt attachment. So basically, this is all tightened down. Belts still need some tensioning, sure, in a minute. I guess that should be the XY gantry done. Right? Yeah. Okay, Z-axis belt. I need a quick sip of water for this. Okay, the manual's good, but this part sucks. Like that part of the manual, assembling this, yeah, that's gonna need some reworking. Otherwise, so far so good, but like, wow. Okay, so this is basically just the Z belt, and this should be fairly easy. Remind me to put the stops, the stoppers for the Z-axis rails back into a position where they're going to stop the rails from sliding off the top in a second. Right, so these belts should be easy, yeah. So they just go out the bottom. Yeah, so that rail is back a bit, so shouldn't fall out. They just go out the bottom around our gearing units that we actually built, I think, in the very first one of these build live streams. Back out the top. Through the tensioner. Around the angry idler. And then, wow, these are way too long. It's like, look at how much these are too long. Are they just shipping the same belts for the 350? Nah. Well, I guess it would be the correct length for the 350 kit as well. I think they're just not cutting these two sides, and belts are pretty cheap. So why add an extra SKU just for a 300 kit? They might also be shipping the same ones for the 250 size. Oh, I just realized I missed the super chat by Andrew Rogers like almost an hour ago. But thank you for the 10, Andrew, and thank you for the 100 Norwegian crowns. 3D tech design as well. That is Anton Monson, right? With that shirt, you serve a beer on me. Greetings from Scandinavia. I mean, I'll have a tea once I'm done with that. I don't drink, but thank you.
Greetings from Scandinavia.
That is too tight. How much does beer cost in Scandinavia? A lot. Everything is expensive up north. I don't want to make this too tight yet. Isn't there a printed part for the Z cutouts? What do you mean for the Z cutouts? Would there be a printed part for that? Is the camera walking away? For there? If there is one, I don't have it. It's not in the electronics box either. Yeah, there might be a decorative part for this, but I don't have it. So yeah, the printed forward. We already zoomed in. The printed forward can only include the parts that you need to get a printer that prints. So you don't get like all the what do they call it? The skirts on the bottom, the skirts that hold the fan and are basically decoratively closing off the bottom. You don't get those. You just get the parts that I guess are required for you to print those parts on your own. Then also, I think all the panel mounting parts are not included in the PIF kit. So that's another one of those parts that you could just print yourself, basically. So all the panel parts are included with the FormBot kit, which means like the acrylic panel parts, but the mounts for them are not. I think also the screws and fasteners and all that are also included with the FormBot kit, but not the mounts and stuff, not the printed parts for the mounts. So same deal again here. There's our gearing unit for the Z drive. Belt goes through. How do you tension the Z belt? Pull tight and pull pull it tight and tighten the clamp. No, this is Voron. Come on, part-time Ronin. That would be too easy. No, so the idlers up top, the idlers at the very top of the printer that I've already fed the belt through on that first corner, those contain an M3 screw that also serves as a tensioning mechanism. So that red part, I guess you can see it back there, maybe. That red part, that you can see that can move up and down, and that's a screw on that on the top part that is actually pulling that tight. So everything on here is like rigidly tensioned with M3 screws that actually move the accent parts up, and then the belt kind of pulls down on it, and basically all you're doing is you're pulling it up with the screw. and the belt is the counter force to that. Again, belt is way too long here. But I'd rather have it too long than too short. Hendrik is asking, hey, how's it going? How are you making progress? Well, this one actually requires some thinking, which is nice as a challenge. But sometimes it's nice not having to think. So we're making progress. I said mechanical assembly would be done. I think we're getting there. We are nearly there. So 2 more belts on the Z-axes. Because yes, these are 4 independent Z-axes. Something smells burnt. Might just my fear of something not working out coming through. Might also have been the fly that's in here that you might have seen flying around, getting a taste of that infrared heater that's set up in front of me. So 1 more. You go through the bottom. Last 10% I have to work. I mean, how much stream time do I have so far? Can't be that much. This is like the 4th stream, right? So 12 hours. And I was told it would be 25. And I don't know where those remaining 13 hours are going to be, because the manual is pretty much at its end. Soldering iron is off, yes. OBS is telling me we've done 3 hours and 25 minutes so far today. Yeah, and I can definitely feel those 3 hours and 20 something minutes. So I'll be getting these belts in. And then that's going to be it for today. And next time I think we can do electronics. Yeah, getting a do-it config on this is going to be interesting. Cabling and debugging. I mean, Jochen, what do you mean debugging? There's not going to be any debugging. This thing's going to, we're just going to fire it up and it's going to be flawless. What's your, debugging? I'm going to have to do debugging. No trust in the build. Disappointed. Wiring looks time consuming if you don't have a wiring loom. Yeah, definitely wiring on any 3D printer build is like both the part that I enjoy the least and the part that takes the most time. Because when you're building something like this, you're making progress, you're building stuff, and it's starting, like right now, it's starting to look very much like a printer. And then when you do wiring, it's like, well, I already have a printer. Like, what's all this work I'm doing? This is not progress. This is not moving things forward, and that can be kind of demotivating. But it's part of the job of building a 3D printer. So unfortunately, we're not going to have that joy of a lot of wiring. Because I have a wiring loom. I actually have 2 wiring looms. I have one that I ordered off of Fermier Labs. That is probably a great choice if you're just building a normal Voron. But of course, I'm not building a normal Voron. I'm jumping into this head first. I'm already building a special Voron with a Do-It 3, which uses different connectors than the regular SKR boards, or the Spider board, which is, I guess, Spider or Octopus or whatever board you can use. And I'm also using Mosquito Magnum Plus, which has slightly different wiring. So, yeah, That's Fermilab's wiring loom would have been good for a regular build. But then Lineo also sent me another one where they were like, hey, you know, what do you need? We're gonna make you one. And they crimped one up. And I'm not sure if that is a service that they're offering to everyone, but that's probably a couple of hours of work saved just by having that that custom-made wiring loom. Printed's going to be beefy, yes. I mean, supposedly, Magnum Plus is only like 30% heavier than the regular Mosquito. Is it the Mosquito or the Mosquito Magnum? Supposedly it's not that heavy, but it's a chonker. Yeah, it definitely is a chonker. As is this printer. I mean, there's nothing normal to start with here. Okay. We have a happy wrecker. So let me put those stops back in the top position so we're not destroying anything. So can I move this? Can I manually move this Z-axis without breaking stuff? Let me try. That is skipping because that is not tensioned well yet. There. Nope, that is tension from the bottom. Okay, that's good. That's tight. That's tight as well. This one could maybe use a bit. Since we're not doing, these belts are not riding on motor axles. Since that is not the case, we don't need to worry about breaking the bearings in the motors, because if you have pulleys with a ton of stick out, that might be an issue where you're, I think there's 625 bearings. You're still skipping. Wow. Interesting. Why are you still skipping? There we go. Uh-huh. Smoothing. Yeah, that is looking good. That is looking like a printer. Okay, let's give the XY a bit of a belt tension. So belt tensions are actually all up front. Where is that one? There it is. That's the belt tensions right there. So these belts are loose. I might need to reclamp them because they're like, they have very, very little tension. Though maybe that's gonna be. Oh yeah, nah. This is gonna be fine. That's good. And then the other side as well. Just some preliminary tensioning. Yeah, that one doesn't need much. Okay. Make sure the XY belt sits flush in all idlers. Yep. I cannot see into this one, but the ones in the back. Yeah, by the way, this backside looks fantastic. With all the... Maybe you can get some light on this? No? There we go. So this backside with the double belt structure. With the double belt structure? Camera? Yeah. That looks nice and beefy. It's unfortunate that that is the backside of the printer and you're never going to see that in use, especially once it's covered up with a what's it called? With a panel, with a cage, with a cover. All right. Let's give the XY a bit of a whirl. Haha. So this. There's like 0.5 millimeter that I can push the printer left side back, so that might be slightly off. It might be from, it can't be from belt tensioning. And up front, it should be the other way around. Yeah, it is. So this is slightly off axis by like 0.5 millimeter on one side. That's running smoothly. That's running smoothly as well. It's interesting to feel like all the phantom forces that happen with the Core XY system. Like, it's easy to move it diagonally, because then one motor is turning and you kind of over that initial holding force, that holding torque that a motor has. It's very easy to move diagonally, one direction and the other. But if you try to move it randomly by hand, it starts to give you some very strange forces that react to your movement. Okay. Mystery God's asking, is it possible to use 1.8 degree motors for the z-axis and then 0.9 for the x and y? I guess it is, but 0.9 degree motors are limited in how fast they can go before they run out of torque, because you have double the step frequency, which also means double the. I should not lean on that. Wow. They have double the back EMF, basically, if my intuition is correct about that. So, right. That is it for this stream. We have, as promised, the mechanical assembly complete. It is I present to you a Voron 2.4 that has no wiring or anything to it. What is still missing? We're missing drag chains. We're missing a wiring loom. We're missing crimped connectors on all the connectors that need crimping, such as the probe, the motors, the Z-axis motors are going to need the, what are they called? JST VH connectors as well. Wiring loom, thankfully. I almost dropped the Mosquito Magnum Plus. Wiring loom, thankfully. It's pretty much all done already. Yeah, the bed needs to go in here. The bed is already assembled. The bed is already assembled. Has all the parts on it. So I need to wire in the fuse for that. Electronics mounting. We can do that on stream. I'm gonna print up a mount for the Duet 3 6HC for the main board and the 3HC expander. But basically, I think what I'm going to do is I'm going to have this thing pre-wired for the next stream, so that all the parts are in here that need wiring, as well as the hotend needs to be installed with all the crimps on there, drag chains on there, all of that. I don't think I'm going to have panels for this entire build, because the panels are really optional, more or less. They do make the printer look really cool. There is the part where you have your filament spool mount and you have that feed-in mechanism, though that doesn't mount to the panels though. However, it is not, those parts are not included in the printed forwards kit. So I think I'm going to skip that as well and stick to just the basic printed forward build. But yeah, like I said, that stuff I'm going to have to do before the next stream. I think I might show a time lapse or something on the next stream, but no promises there. Anyways, thank you all for watching. Thank you all for being here. Lens distortion makes it look weird. What lens distortion? Yeah, oh yeah, there is some wonkiness to that. Thank you all for being here. Thank you all for sticking around. Thanks for everyone who has subscribed, as did Tinjan Tumisin, Tom Chow, Mr. I've got these subscribers that people just subscribe. I have those here as well. Oh, I think no, I mentioned Andrew Rogers super chat. Thank you all for being here. Get subscribed if you want to see more streams like this. Here's the thing though with subscriptions. So YouTube shows me which videos people subscribe on. So if you subscribe on a video like this one, that shows me, hey, that is something that people actually enjoy. If you don't subscribe on a video like this, it's like, well, I guess that's a video that didn't really engage people. So, like I said, I see which videos people subscribe on. YouTube shows me that stat, and yeah, if you want to literally see this type of content more, you stuck around through it, then get subscribed on this very video. Thank you all for watching. Keep on making, and I will see you all in hopefully 2 days. I'll have to see how well this wiring goes. Thanks. Bye. No, don't unsubscribe and resubscribe, please.